On my left hand, I have ESP32P4 development board for high performance from Espressif, and on my right hand, I have Arduino Giga R1. This is also a high performance device. The trend these days is to not only perform simple tasks but also collect data such as voice and images and transfer them to servers or clouds. It seems that high-performance devices focused on multimedia are more and more being released on the market. They have relatively better performance than other microcontrollers, so their price is also relatively expensive. They include functions such as larger flash memory, USB OTG, DMA, camera connection, and graphic accelerator, H.264 encoder, fast CPU clock, so they can be very useful depending on the project you are doing. So it's good that we have so many options. We just have to choose the right MCU for the project we are working on. Both devices were released with the title of high performance, so what are their benchmark results? This benchmark test used CoreMark version 1.0, which I think is probably the easiest way to compare because it scores a single core performance most intuitively. If I get a chance, I will also try CoreMark Pro, which is a newer version. Do you remember this testing? In this test, I have compared the calculations on ESP-IDF and Arduino frameworks with ESP32S3 DevKit-C. The results were slightly faster on Arduino for basic calculations. In fact, the result for general arithmetic operations cannot be very different. This is because they use the same core functions internally. Therefore, the benchmark results of ESP-IDF and Arduino using CoreMark should be almost the same. Before the main game of Arduino Giga R1 versus ESP32P4, I first ran the CoreMark benchmark with ESP32S3. CoreMark scores were 595 at 240 MHz, 396 at 160 MHz, and 198 at 80 MHz. This same test was performed on Arduino. The results are very tragic. As you can see, the CoreMark score dropped by about 20% in the Arduino environment. This doesn't make sense. In my previous test, the results were clearly similar or slightly higher, but this is a very different result. Then what is the issue? I checked that O3 optimization is included in the GCC compile options in IDF, and I was able to add the O3 option by modifying the platform.txt file in Arduino IDE. Depending on the optimization options of the GCC compiler, the performance may vary, which may lead to different results in performance comparisons. This is the result I wanted. As you can see, there's no difference in performance. It doesn't matter much whether you work in ESP-IDF or Arduino environment in terms of performance. However, in order to use some features that are only supported in IDF, the project must be carried out in IDF environment. That's it. Okay, this is the main game. I ran CoreMark on Arduino Giga R1. The left side is for testing the M7, the main core of R1, and the right side is for testing the M4, which is the subcore. Since M4 cannot output calculation results directly to the serial console, I modified the code to output the results via RPC after the calculation is finished. The CoreMark score showed the M7 with an astonishing score of 1906. This is a Cortex M7 running at 480 MHz, so it makes sense. M4 is a 240 MHz Cortex M4 and recorded 550. It is about 5% lower than the ESP32S3 that operates at the same 240 MHz. It seems that the performance of the low power core is better than expected. Here too, you can see that the scores are clearly different depending on the optimization option. This time, it's ESP32P4. I naturally thought that the CPU clock setting would be 400 MHz. However, in the current ESP-IDF 5.3.0 and 5.3.1, the maximum frequency of P4 could only be set to 360 MHz. It seems this is something that Espressif should officially support sooner or later. Anyway, the CoreMark score at 360 MHz was 1092. it's about 50% lower than the R1. The most disappointing thing is that I cannot test at 400 MHz. I wanted to test the maximum performance of the P4 compared to the M7 core of the R1. I wonder how much of difference there will be. So this is the result of my testing, and I think it'll be good to think of it as having roughly this level of performance. Here's a chart adding ports benchmark results. The most notable one is the Teensy 4.0 board. This is crazy, this is a monster. It has a Cortex M7 but has a clock speed of 600 MHz. That's why it performed better than the Giga R1. It would probably be great if you don't need to connect a camera or external display and use it with a low power Wi-Fi Bluetooth module like the ESP32C6. I'd love to try out the Teensy if I get a chance. These development boards are suitable for multimedia related tasks. The display can be connected and it can be useful for data collection for AI, such as acquiring images from a camera and collecting audio data from a microphone. In addition, simple tasks can be processed as a standalone. If I have a good project idea that can utilize these devices, I will share it with you. Alright, that's it for today. Thank you for watching. See you on the next project.